Chalo. Let us discuss another very important thing now, which is known as structural relaxation. Which is known as structural relaxation. Let me just check the recording is happening good. Yeah. Okay. So structural relaxation. See, हर एक इंसान को रिलैक्स होना ज़रूरी है, रिलैक्स होना ज़रूरी है. ऐसे ही देयर आर मटेरियल्स विच आर अंडरगोइंग रिलैक्सेशन. So we have substance. Now this substance is of two types, crystalline and amorphous. Now crystalline में the atoms are arranged in a certain configuration. We apply stress and we try to deform it into a position A. Now the atoms are not in equilibrium. They are not in equilibrium. So this causes something known as internal stress. That is why I said that stress is developed inside the material. You apply a force and stress is developed inside the material. Okay, stress is nothing an external phenomenon, it's an inside phenomena. So now internal stress has been developed. Now if we talk about the amorphous materials, so basically crystalline is थोड़ा ज़्यादा solid and amorphous is थोड़ा ज़्यादा कम solid. ठीक है, कम solid. So now amorphous में भी atoms are arranged at in a certain configuration. They also undergo deformation, and once they undergo deformation, some particles are close enough, some go far. Now this is also a state of non-equilibrium, and again we have something which is internal stress which is developed. So एक बात तो पक्की है, whether crystalline or amorphous, both of them are in internal stress if certain deformation is happening. Okay. Now consider this. This is you, my dear friend. This is you, my dear friend. Now you go into college. You are an individual identity. You go into college. You meet a lot of people, seniors and everyone. उसकी वजह से क्या होता है? You undergo a lot of things. Like you might not sync with them. They may make fun of you, या फिर they may mock you, या you help them, they do not help you in return, or there may be many things, a lot many toxicity going on. This will lead to something known as internal stresses inside you. Internal stresses will be developed inside you. Now there are two possibilities. Either you go in isolation, you isolate yourself and work on yourself, or you discuss with everyone. अब जो लोग सबसे ये डिस्कशन करने जाते हैं वो पागल हैं, वो बेसिकली पागल है. वाई सो? बिकॉज हमें पता है जो हमें स्ट्रेस क्रिएट कर रहा है. वी आर ट्राइंग टू डिस्कस विद देम दैट डू नॉट डू दिस, एंड what do you think? Will that be of any help? Not at all. So you isolate yourself and work on yourself. Now you become a completely different person. Person A is not same as person B. It has gone certain modifications. It has gone certain changes. It has slightly deformed from the state A. Am I correct? So that is what is happening here. So whenever internal stresses are developed inside a material, internal stress is developed, what will happen is, through a process known as solid state diffusion, means the material is still in solid state. But because of the use of thermal energy, something known as solid state diffusion happens. It will deform and come back to equilibrium. It will try to come back to equilibrium. During that process, some products or some materials may reach the exact equilibrium, may not reach the exact equilibrium, may be somewhere in between, but something which has happened is for sure, that is deformation. Why is it important? ऐसा क्यों? Let's say I am a very sunky scientist, sunky psychopath scientist. I have created a cube of 4 mm into 4 mm into 4 mm, and I have made this in Mysore, where the temperature is 21 degrees Celsius. Beautiful temperature, beautiful area. 4 mm into 4 mm into 4 mm. I do not want an mm of difference in it or a micron of difference in it. I have developed this in 21 degrees Celsius in Mysore. So because of working on this wax cube, I have made the atoms in a certain arrangement, which is 4 mm into 4 mm into 4 mm. Now I come back to Delhi in such a bhasad of 32 degrees Celsius. Now because of the thermal energy from the environment, it will release the stresses. It will release the stresses. Now my cuboid has become 4.2 into 4.2 into 4.2. This is absolutely bullshit. I do not require it. It is not serving me the purpose. That is why the phenomena of stress relaxation is very much important. And that is why two properties happen: creep and flow, because of stress relaxation. I'll discuss it. Just one more point left. What is the significance of stress relaxation in dentistry? Why we are doing it? See, this is the tooth preparation which I did. I had explained you why it looks like this, because इसके ऊपर एक crown आता है. So to make that crown, firstly we develop that crown using wax. I have developed this crown using wax, and now this wax will undergo a process known as casting to develop a metal crown. Okay, to develop into a metal crown. Now this wax casting must be exactly, wax pattern must be exactly the same dimension as I want the crown. Exactly. Micron का भी फर्क हुआ, there will be gaps or it may not fit. Now as soon as I remove it from the tooth structure, there are chances that this wax will undergo stress relaxation. Dimensional changes will be of no use, a harm to the economical side of dentistry and a harm to the economics of the dentist. Finances खराब हो गए, हमारा तो क्राउन नहीं फिट आ रहा है, बेकार हो गया सब. दैट इज वाई अगर उस डेंटिस्ट ने, अगर उस कास्टिंग वाले ने फिलिप्स पढ़ी होती तो उसको पता होता कि ये प्रॉब्लम होती है, ही और शी वुड हैव टेकन स्पेसिफिक मेजर्स. पर नहीं, हमें तो फिलिप्स पढ़नी नहीं है, हमने मल्लापली पढ़नी है. पढ़ लो मल्लापली, यही होगा फिर. चलो, let us go ahead. Okay, so before going to creep and flow, let me illustrate what is creep and you give you an essence of what is creep. Okay, देखो, एक सख्त लौंडा है, सख्त लौंडा एकदम मेरे जैसा, ठीक है, एकदम मेरे जैसा. So what happens is, जब भी एक सख्त लौंडा वैसे सख्त रहे, he won't be giving a fuck about the world. But जैसे ही वो अपनी पसंदीदा औरत के पास जाता है, पिघल जाता है. That is what happens here. सख्त लौंडा जब पसंदीदा औरत के पास गया तो वो पिघल गया. पिघल गया इज इंपॉर्टेंट हियर. क्रीप. ठीक है. लेट अस से यू हैव ऑर्डर्ड अ चीज बर्स्ट पिज्जा फ्रॉम डोमिनोज. आपने चीज बर्स्ट पिज्जा ऑर्डर करा डोमिनोज से. यू पिक्ड अप अ स्लाइस फ्रॉम इट. अब उस स्लाइस में से देयर इज चीज हैंगिंग फ्रॉम इट. यू hold this pizza here, hold it here. So what will happen? Cheese with time under its own weight will slightly drop down and elongate और ऐसे flow करने लग जाएगा. This is creep. This is creep. So what is creep? When a metal near its melting point, near its melting point is very important so that atoms can at least move. Near its melting point, when a constant stress is applied, it kind of undergoes a strain or increase in length with time. This is known as creep. Time dependent plastic strain under constant load. Under constant load. Similar kind of a term is sag, same as creep. Let me explain you what it is. Let's say that we have a premolar here, and a second molar here, second molar. My first molar is missing. So what I do is I firstly cut this crown and provide a bridge over it with the missing tooth. This is known as bridge. So the number of teeth inside this, including the ones that are being cemented over the existing tooth and the missing tooth, this is known as span of bridge. Okay, span of bridge. So while I am making a metal ceramic bridge, तो उसमें अंदर की तरफ there is a metal, and over this there comes something known as ceramic. Something known as ceramic. So to set this ceramic, we need to fire it. We need to put it in a bhatti. We need to put it in an oven to bake it. So this firing of porcelain is a process by which it sets. What if the metal underlying this has a melting point near to this firing temperature? What will happen? It will start to creep. Why so? Because this prosthesis is having a weight. Now because of this weight, it will start to creep under its own weight, coming closer to the melting point. Now this happens in long span bridges. I'm talking about 5 units, 6 units, 7 units, endless. Okay, this happens in there. Therefore, long span bridges are not indicated, actually, also recommended. Also, if you are making use of it, the alloy or the metal must not have the melting point closer to the firing temperature. This is very important, है ना? Philips पढ़ी होगी तो ये दिक्कत नहीं होगी. Now another similar kind of creep happens in amalgam. Let's say this is a tooth over which I have provided amalgam filling. Now amalgam has two phases. It has a weak phase and it has a strong phase. Whenever I apply some force, maybe by chewing or by the tongue musculature or by something else, so the force applied will weaker phase पे act करेगा and it will lead to stresses, and because of the stresses there will be deformation. Because of the deformation, what will happen? ये था हमारा tooth. The filling will change in size. There will be gaps from which bacteria can enter and cause caries again, infection again. So amalgam has creep in it. That is very important to understand. How to avoid this? You need more of the stronger phase and less of the weaker phase. You'll read about it later when we'll be studying about amalgam. Okay. So next thing is after creep, flow. Creep is for crystalline materials, flow is for amorphous material. You must understand that. So have you seen a wax sheet? Whenever you hold the wax sheet like this and heat it, it will slowly start to curve under its own weight. This is known as flow. So the potential to deform under a small state load, even its own weight, that is a problem. That is flow. So how to measure it? Let's say you are a scientist and you have developed a new material that is going to replace amalgam. Now you need to see the creep and flow of that material so that it can have a good advantage over amalgam. अब उसको measure कैसे करोगे? There must be certain criteria to measure it. How to do that? See, वैसे तो creep and flow can be measured in every type of stress, but we prefer compressive stress. No reason, no logic, just mentioned in Philips. Compressive stress is used and percentage decrease in length is noted. We compress the substance, we compress the specimen and see the percentage decrease in length, and that is how we get to know कि इसका creep या flow कितना है. Next very important topic coming up is color and